All graphs have something in common, all these graphs. The chart on the next page shows all the possible combinations of position graphs, velocity graph shapes, and acceleration graph shapes, stacked 3 high. Position is on top, velocity is in the middle, and acceleration on the bottom. Don't memorize the chart, don't write down the chart. Instead, just look for the patterns so we can make these ourselves. Goes by columns. There they are. Leave it here, pause it, take a look at it, come back to it after we go through this a little bit. All the top rows are position graphs, velocities are in the middle, and accelerations are below. How to read this chart. All 3 graphs that are in the same column have the same color, show the same motion. Gray, we're standing still. Position not changing, so we have no velocity, no acceleration. Red, we're moving forward with a constant speed, so we have a constant positive velocity, no acceleration. If we have a constant velocity, we have 0 acceleration. If we have a constant velocity, we have 0 acceleration. One more time. If we have a constant velocity, we have 0 acceleration. I promise you somebody's going to mess that up on the AP exam. If not, my test. Orange, moving backward with a constant speed. So we have a constant negative slope, constant negative velocity, no acceleration. Yellow, moving forward and speeding up. Our velocity is increasing in a constant way. The slope is constantly changing. So our velocity is constantly changing. So we do have an acceleration, a constant positive acceleration. We know it's a constant positive acceleration because our velocity is moving more towards positive numbers, getting away from 0. Green, moving forward and slowing down. This slope is approaching a 0 slope, which means we're approaching 0 velocity here. Started out with a positive slope, so we start out with a positive velocity, and then we're approaching 0. Negative slope for velocity versus time graph, negative slope for acceleration versus time graph. Blue, we're moving backwards, so we started with some position way up here, and we're going back to a 0 position. And we're speeding up, so our slope here is 0, and then it's getting bigger and bigger and bigger as we go along. So our velocity is 0, and then it's getting bigger and bigger and bigger as we move along. Because our slope here is negative, we have a negative velocity. If our velocity is getting farther and farther away from 0 in the negative direction, going towards more negative numbers, then that means we have a negative acceleration, right? Moving backwards and slowing down. So again, we start with some position that's not at 0, and then it's going to drop back down and approach a 0 slope, which means a 0 velocity. So here we have a big negative slope going towards a 0 slope. So we start with a big negative velocity going towards a 0 velocity. Now we're going towards positive numbers. So that means we have a positive acceleration. If there is no acceleration, position graph is a straight line and velocity graph is a flat line. Objects moving forward have sloping up position graph and velocity graph above the axis. But note that moving forward doesn't tell us anything about the acceleration. Objects moving backward have a sloping down position graph and a velocity graph below the axis. But note that moving backward doesn't tell us anything about acceleration. If the object speeds up, the position graph gets steeper. I might be in the way. Sorry if I'm in the way. The velocity graph moves away from the horizontal axis, but speeding up doesn't tell us whether the acceleration is positive or negative. If an object slows down, the position graph gets less steep. The velocity graph moves toward the horizontal axis, but slowing down doesn't tell us whether the acceleration is positive or negative. Positive acceleration means a position graph is any part of an upward opening parabola. Also, positive acceleration means a velocity graph has a positive slope. But positive acceleration doesn't tell us anything about the direction the object is going. So if you have an object with positive acceleration, you can't know that it's moving forward or backwards. Negative acceleration means a position graph is any part of a downward opening parabola. See that? Full downward opening parabola. It's negative acceleration. Negative acceleration doesn't tell us anything about the direction the object is moving. I'm going to stop the video here. Seriously, go back and have this stuff, have these patterns imprinted in your brain. It will help you tremendously.